Hey students, we are on notes 6-2. So the title is Proving Quadrilaterals are Parallelograms. So the connection between what we're doing today and what we did yesterday is yesterday we had the properties of a parallelogram. So we know it's a parallelogram, we have these properties. Today we are actually going to be talking about the converse. Okay, so I know when we had the converse of parallel line theorems, some of you struggled with remembering that you had to use the converse. You will have to remember when you're supposed to use the converse, and I'll try to make that very clear for you. Okay, we're going to start off with a proof. So in this proof, we are given that we have a parallelogram. Let's go ahead and write our given. So I'm going to write ABCD is, and instead of parallelogram, to save writing, because that is a big word, you can just put the little parallelogram symbol, or you will see me doing this. So those are the two ways that you can shorten the word parallelogram. So we have a parallelogram, and we have that FG bisects DB. All right, so let's go up here. I know that if I have a segment bisector, I'm going to have two steps. I'm going to have to say that I have a midpoint, and then I'm going to have to say that I have the two segments congruent. Okay, segment congruent to segment. So remember, that did have two steps that went with it. Okay, so let's look at the picture. We are trying to show, first of all, A, B, C, D. We have a parallelogram, and we are trying to show that FE, I'm just going to put some yellow on this. I'm trying to show that FE is congruent to EG. So I'm probably going to have to use CP, in this proof, somehow using the parallelogram to help us. Okay, and I'm thinking that I might be using those little triangles right there. Okay, so let's go through and see what we can come up with. Let's take care of this first. So I know that E is midpoint of DB. Okay, so it's coming off of this statement to get this one because this is review. Well, let's put our given. Whoops. I'm going to ask you one of the questions. What is the answer right here? Definition of what? Okay, you should have said segment bisector. Okay, definition of segment bisector. Okay, and if we have a midpoint, then we're going to say if E is a midpoint, I like putting a dot right there. E is a midpoint of DB, so then that makes DE congruent to EB. And that is definition. Remember, that came off of this step here, just like this one came off of that step with the vocab word. Definition of midpoint. All right, so what else do we have in the picture? Well, I also know if I'm looking at these two triangles, I'm going to put 1 and 2 in my picture. I can say angle 1 is congruent to angle 2, vertical angle theorem. So I can mark this piece. The parallelogram has to give us something for the picture. Okay, so in my parallelogram, I know because I have a parallelogram, these lines are parallel. Okay, and if these lines are parallel, these angles are equal to each other. Okay, so let's put a 3 and a 4. Remember, you can use the letters or you can put numbers into the picture to help you have an easier time. Okay, so in this picture, because I have a parallelogram, I need to say that my lines are parallel, okay? Because we don't have alternate interior angles unless I have parallel lines. I don't have parallel lines unless I had the parallelogram. See how all of that flows together? So I need to say DC is parallel to AB. And this is where we are going to use definition of parallelogram. Okay, what is the definition of a parallelogram? It is a quadrilateral that has opposite sides parallel. So my opposite sides are parallel because I have a parallelogram. Okay, see how that flows together? Now I can say angle 3 is congruent to angle 4. Okay, and I have my lines are parallel. So now I can say if lines are parallel, then alternate interior angles are congruent. I hope you guys see how that all flows together. So now we have angle 3 is equal to angle 4, angle 1 is equal to angle 2, and this segment is equal to this segment, and I clearly have angle, side, angle. So now I can say my two triangles are congruent. If I name this triangle DEF, what's going to fill in that blank there? All right, if you said BEG, you are correct. And this is angle, side, angle. And then I can say FE is congruent to EG, CPCTC. In my opinion, for what you have learned with proofs, that was not hard. This was new, talking about that we can now use definition of our shapes. After we have learned them, you can use them in your proof. This was old, definitely old, definitely old, old, old. Okay, nothing in this proof was new except for this part right here. Okay, down to the bottom. All right, these are the 6 properties that we have of a parallelogram. And so if you think of these as if-then statements, okay, all of these would be preceded by if parallelogram, then two sets of opposite parallel sides, or two sets of opposite sides are parallel. Two sets of opposite angles are congruent. Two sets of opposite angles, or sides are congruent. Two sets of angles are congruent. Consecutive angles are supplementary. If you have a parallelogram, the diagonals bisect each other. If you have a parallelogram, the diagonals form two congruent triangles. So you think of this as an if-then statement. Then when we get down here, there are actually 6 ways. Now we're going to write this on the next page, so that's why I'm not going to write it right here. But I want you to know that you're going to have, for all 6 of these, if, and you're going to fill in this statement, then we have a parallelogram. Because what we're trying to do is prove that we have a parallelogram. So that's going to be at the end. We're proving that we have a parallelogram. Up here, just like this, the converse, we weren't proving the lines are parallel. We were proving that we had alternate interior angles. Those were alternate interior angles because you had parallel. So you need to know that we are using the converse. Okay, go ahead and turn your page. Depending on what book you use, there are 5 or 6 ways. There are technically 6 different ways to prove that a figure is a parallelogram. Okay, so is the quadrilateral a parallelogram? There are 6 ways that you can confirm a quadrilateral is a parallelogram. All right, number 1, if both pairs of opposite sides are parallel, look at the picture, then the quadrilateral is a parallelogram. By the way, this is the definition of a parallelogram. It's actually the converse of the definition. Okay. So we would write if opposite sides. Now, when I say opposite sides, I am letting you guys get away with this, that I am meaning both pairs. So I am assuming you know we're talking about both pairs unless I specifically say only one pair, because there is a time when we'll use only one pair down here. Okay, so if opposite sides are parallel, then you have a parallelogram. Okay, now we're going to have to be writing these statements out, so be sure you're writing them down. This is where you will refer back to for your homework. Okay. All right. Next, if both pairs of opposite sides are congruent, look at the markings. This is the markings for parallel. This is the markings for congruent. Then you have a parallelogram. This is actually the converse of a theorem. All right, so if opposite sides congruent, feel free to use words if you want to use words, then you have a parallelogram. All right, if opposite angles are congruent, opposite is across from each other. This is consecutive. This is opposite. All right, so, and this is a theorem. Okay. If opposite angles are congruent, then you have a parallelogram. Same thing. I'm assuming you are understanding we're talking about has to be both pairs. All right, if the diagonals bisect each other, so this is equal to this is equal to this, the diagonals are clearly bisecting each other. This is also a theorem, so we can have the converse. If diagonals, and you have to put bisect each other. So this one is the longest one. Okay. Actually, this one's the longest one, but there's a lot of words there. Then parallelogram. Okay. And then this has been proven for us already. We don't have to prove it, so you're going to take it as a fact because it has already been proven for us. If one pair of sides are both, is both. One pair, a pair is, yes. One pair is congruent and parallel, then it's a parallelogram. Okay, if, this is how you'll write this, one pair sides parallel and congruent, then you have a parallelogram. Okay, be sure you look at how I'm writing these. You can write out these words, that's fine, that I've shortened. You can write out the words, but you cannot shorten this anymore. All right, the last one, number 6, which was left out of this textbook, but it is included in other textbooks. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. And this is a theorem. So in this picture, I want you to look. Consecutive angles go this way, and they go this way. So that means they have to add to 180. This is the representation to show that if you add this plus this, it leaves 180. And if you add this plus this, it leaves 180. So this is a representation of that. Unfortunately, this one's going to be the longest for you to write. Okay, so if an angle is sup to both consecutive, and you can use angles right here. If an angle is supplementary to both consecutive angles, then you have a parallelogram. All right, so that one will be the longest for you. All right, so let's apply this. We're not shortcutting this, okay? You have to write the statement out. All right, so number 1. Can you prove that the quadrilateral is a parallelogram based on the given information? Okay, so in this picture, this is equal to this. This is equal to this. This is the picture for number 2 above. So we're going to say yes. And then my reason is if opposite sides are congruent, then I can squeeze that right here. Then it's a parallelogram. Okay. All right, number 2. Do you have enough information? Look up here. Do you see this picture anywhere up here? So can you prove that this is a parallelogram? And as you just found out, the answer is no. All right, number 3. Can you prove this is a parallelogram? This one right here. So this is yes. If one pair sides parallel and congruent, then it is a parallelogram. Okay. All right, this one is showing diagonals are bisected. So this is yes. If diagonals bisect each other, then it's a parallelogram. Number 5 is yes, it's showing opposite angles are congruent. So if opposite angles are congruent, then you have a parallelogram. And number 6, this is yes. This is opposite sides are parallel, which is the definition of a parallelogram, but we have to write it as a theorem or converse. If opposite sides are parallel, then it is a parallelogram. That is the converse of the definition. All right, turn over. Same thing. So now, without looking at the other page, see if we can answer these. Okay, so letter A. These are showing parallel. These are showing parallel. So write out your statement. If opposite sides parallel, then you have, and guys, remember, you can do this, then you have a parallelogram. Or you can write out the word parallelogram, or you can put the shortcut. All right, letter B. What would you write? All right, so you know if you got that right or not. Letter C. Showing opposite angles are congruent. Letter D. All right, tell me what words are missing. All right, what words go in that blank? All right, moving on. Letter E. If one pair sides are parallel and congruent, then you have a parallelogram. This is showing congruent. This is showing parallel. Make sure you know your markings. Okay. All right. Based on your markings, decide if each figure is a parallelogram. That's what your whole worksheet is over. All right. So justify your answer. So just to make this go shorter, we'll come back over here, and I don't know, you cannot do this in your homework. Okay, you have to write the statements out, but just for the notes, 1, 2, 3, 4, 5, or 6. If it's a yes, give me a reason with a number. Okay, so look closely at this one. Are opposite sides congruent? So this is a no. Okay, so pay attention to the markings. It would have to have a 1 and a 1, 2 and 2. Okay, Number 3. Okay, so 2 is a no. Number 3. So you guys have to make inferences about the pieces that they gave you. Why did they give you these pieces are equal? Because I can say these are parallel if alternate interior angles are congruent, my lines are parallel. If alternate interior angles are congruent, my lines are parallel. That's not the reason it's a parallelogram, though. The reason it's a parallelogram is reason number 1. If opposite sides are parallel, then it's a parallelogram. Okay, so this is reason number 1. All right, next. One pair of sides are parallel, one pair of sides are congruent, just like this one. That is reason number 5. Okay, and even if you need to draw arrows to make sure we know these reasons are coming from the other page. All right, let's see what's going on in here. So this one has a little bit of thought that we have to put into it. So I am seeing that I have side angle side. Okay, so that means I can also say CPCTC, and I could say this piece is equal to this piece. Okay, well, I know if I have the vertical angles this way, I also have the vertical angles this way. So I also have side angle side with these triangles, and I also have another CPCTC that I could use to show those pieces are equal. Okay, so it's just using CPCTC. This would be a great proof. So the reason is if opposite sides are congruent, then I have a parallelogram, okay, which is number 2. All right, number 6 is the hardest one on here, and I would not put one like that on a test, so we're going to come back to it. Number 7, think about things that I did up here, okay, and tell me, is number 7 a yes or a no? It is a yes, and this is how. So I have vertical angles that I could mark, and then I have angle, angle, side. So I can mark the diagonals. I could say this diagonal is equal to this diagonal, and I could say this diagonal is equal to this diagonal because of CPCTC. CPCTC tells me, after I have the angle, angle, side, tells me that I have those diagonals congruent. I don't know anything about this piece just yet, but I could show those two pieces are equal as well. But my reason would be number 4. If the diagonals bisect each other, then it is a parallelogram. All right, number 8 is a yes, and it is reason number 2. Okay, number 9 is a yes. Would you tell me which reason it is? 1, 2, 3, 4, 5, or 6? It is reason number 3. All right, next section. Now, I am going to recommend that you grab a pencil to do this section because we're going to mark what's over here in the picture, do what we did up here, but then we're going to erase it when I get to the next one. That's where it gets confusing, is people who don't erase it. All right, number 10, angle RDC. RDC is right here, is congruent to NAC. Looks familiar. ARC is congruent to DNC. Make sure you pay attention to these angles. So this is a yes, and what would happen is alternate interior angles would say that my lines are parallel this way, and then alternate interior angles would say that my lines are parallel this way. So it would be reason number 1 Again, you cannot do this on your homework. You have to write out the statements. So reason number 1 on the other page, if opposite sides are parallel, then it's a parallelogram. All right, number 11, I want to know yes or no, and I want to know if it's yes, if it's a number, which reason. So yes or no, and then if it's yes, give me the number. All right, so I erased my markings, and I'm going to put RD. RD is congruent to AN, and RN, which is the whole thing, is congruent to RA. So having this piece congruent to this piece does not help me determine that it is a parallelogram. So the answer is no. Okay, erase. I don't have a good eraser. All right, angle ACN, angle RCD. So we know those are equal because they're vertical angles. Angle RCA and angle DCN. Nothing about vertical angles proves that lines are parallel. Okay, so it doesn't show that it's a parallelogram. Nothing about vertical angles shows that it's a parallelogram. All right, number 13, RDAN, RDAN, RADN. That would be yes. Opposite sides are congruent. Opposite sides are congruent. Reason number 2. Okay, so I hope you see this is not difficult. You have 6 reasons to choose from, and you have to write out the statements in your homework. And it is the converse. We are ending with it's a parallelogram. Okay, turn the page. And let's look at some proofs. All right, we are given quadrilateral ABCD. We've got a lot of stuff. Just to save time, because this is a video, I'm going to do this. You are not allowed to do that in your homework. You're going to have to write it out. Okay. All right, so in my picture, got a diagonal. We have a quadrilateral, so we don't know anything about it. I want to prove that it's a parallelogram. So DE is perpendicular. DE is perpendicular to AC. So I have a right angle here. BF is perpendicular to AC. Be thinking about what perpendicular angles or perpendicular lines form. Okay. And then AE is equal to CF. AE. Now, the way I do that, remember, is I kind of trace it. Like that. So I can see that those two pieces are equal. So we've got those pieces are equal. I'm going to put like that. And then we have DE and BF. Put those with 1 mark. Okay, so that is everything that we have for this proof. All right. Here we go. Okay, so we are looking at trying to show that ABCD is a parallelogram. Okay, so if I could show that we have parallel lines and congruent sides, that would be one way. I don't know if I can get up here. We're just going to look and see what happens. Okay, so I think what is going to happen is it's looking like I have side angle side. Okay, but I'm going to have to do that part where I do the subtraction to get it equal to these 2 pieces and get rid of this overlapping piece. Okay, so I know I'm going to have a segment addition postulate. I know I'm going to have the right angles. So perpendicular makes right angles. And then right angles, we're going to have to show that they're congruent. Okay, because I'm going to be using side angle side. So we got to get all that in the proof. All right, so the first thing I'm going to say is that angle AFB and angle DEC are right angles. Why are they right angles? Because we had perpendicular. From the given, we had definition of perpendicular because we had perpendicular in the given right here. Okay, and then I'm going to use that shortcut. Okay, I want to remind you, if you did not use this shortcut that I hope you start using, you would have to have the extra step right here. And this would be transitive, but you would have to say that they equal 90. And you would have to say definition of right angle. Okay, so I'm just going to leave it like that. If you're going to the right angles are congruent, you don't have to have that step in there. Okay. All right, so I've got that my right angles are congruent. I already had that we had pieces congruent except for these two pieces here. So I'm going to use the segment addition postulates. All right, so we're going to say AF plus FE equals AE, and FE plus EC equals FC. Segment addition postulate. All right, and remember what always follows segment addition postulate? A substitution. Okay, so in my given, I've got AE equals CF right here. So if these two pieces are equal, these two pieces are equal. And we have used this so many times, and some of you still skip this step. You have to do this step to do the subtraction. Okay, so if these two pieces are equal, then you can say these two pieces are equal, and I'm only allowed to do this because it's written right here. All right, so then we're going to subtract the FEs out, and we're now going to have the pieces that we need. This is very, very classic geometry. Okay, this happens a lot. All right. Oh, by the way, this is going to go way past 8. Just letting you know. Okay. So now we have these two pieces equal. We're given these two pieces, and I've shown that these two pieces were equal. So we've got side, angle, side. We have got side, angle, side. Right? D, yes, that was the other side. Okay, side, angle, side. So step number 7, show that my triangles are congruent. Triangle AFB is congruent to triangle, what would you put right here? Okay, triangle CED, AFB, and CED are now congruent. So now I can say AB is congruent to CD. And that is by CPCTC. All right, so I am definitely needing that. Okay, I need to know if there's a way I could show these two lines are parallel. Well, what about if I said this angle was also congruent to this angle? It's an alternate interior angle. Okay, so I'm going to put 1 and 2 right here. And I'm going to say in the same step, because it's still CPCTC, those angles are congruent to each other. So then step 9 is I can say AB is parallel to DC. And that is if, alternate interior angles are congruent, then lines are parallel. I can show those lines are parallel. So now I can do this. Okay, and I've got congruent and parallel. So now I can say quadrilateral ABCD. Okay, so number 10, we can just say ABCD is parallelogram. And the reason is if one pair sides are parallel and congruent, which is what we have shown, then you have a parallelogram. That is a great proof. Okay, great proof. All right, number 15. We are actually doing all these. All right, given quadrilateral ABC has diagonals AC and BD. We're just going to put this given right here. BD bisects AC. We've seen that before. So BD bisects AC. So I'm going to have a midpoint. I'm going to have congruent segments. CAD is congruent to BCA. All right. I'm going to have probably vertical angles. I'm probably going to have angle, side angle, which got to get all this in there. And then to show it's a parallelogram, I'm going to, what am I going to do? Oh, I could show my diagonals are congruent. That would work because I've already got these congruent. So then by CPCTC, I can show those are congruent. And then if diagonals are bisected. All right, so that's the plan. Now I just got to get it in the proof. Okay, so step number 1, let's deal with the midpoint because that came first. So E is a midpoint of AC. Be sure you put that part in there. Definition, segment bisector. What does a midpoint make? 2 congruent segments. AE is congruent to EC. Definition of midpoint. That's one of our pieces of our angle, side angle. The vertical angles. Okay, so we got that. And then we were given that these angles are equal, so that was right here. Okay, so I've got my angle, angle, side. Angle, angle. Is it angle? No, angle, side, angle. Angle, side, angle. Angle, side, angle. Okay, so my triangles, AED. AED is this one. So then that is going to correspond. A corresponds with C, so it's going to be CBE. Angle, side, angle. And then I need to say, I really should not have marked my picture until I was ready to. I know that's a little confusing, but I need to say these two pieces are equal now. TE is congruent to EB. And then because these are equal, it is a parallelogram. So ABCD is parallelogram if diagonals bisect each other, then we have a parallelogram. If diagonals bisect each other, then we have a parallelogram. All right, hopefully this is all making sense to you. All right, I want you to pause the video and write this down. All right, this is what I asked you to write down. So now let's do this proof together. What's in yellow is what I'm trying to prove. Okay, lock this in. What's in yellow is what I'm trying to prove. All right, we have a parallelogram, so we're going to have to use some of the properties of a parallelogram to do this. We're probably going to prove these two triangles congruent, use some CPCTC, and then show that pieces of this yellow are congruent, and that's how we're going to prove that it's a parallelogram. Okay, I did put 1 and 2 in place of those letters, so that's why I have the 1 and the 2 right here instead of that. And I've got it in the picture already. Nothing else is marked other than the yellow is what I'm trying to prove, and this is what I was given, and I'm given that I have a parallelogram. Okay, so because I have a parallelogram, I know FA is congruent to DC, and I know FD. So this is going to be kind of hard to mark, but FD is congruent to AC. So we can do it like that. All right, that is if we started with a parallelogram, then opposite sides are congruent. Okay. I have angle A is equal to angle D. This is still in the big parallelogram. Those are opposite angles. So if parallelogram, then opposite angles are congruent. So let's go ahead and mark those. Okay, I am seeing right away angle, side, angle. So these two triangles are congruent by angle, side, angle. If I have two congruent triangles, then I can say FB is congruent to EC because I'm still in the triangle. That's CPCTC. Ignore I have this circled. I have it circled for a reason. Also, AB is congruent to DE. And I'm still in those little triangles, so that's still CPCTC. Okay, then I've got, oh, this has happened so many times. I've got the big piece congruent and I've got the little piece congruent. I need to show these are congruent by subtraction. It's those 3 steps that are classic. Segment addition postulate, substitution, subtraction. Segment addition postulate, substitution, subtraction. Okay, so this is going to be my segment addition postulate, saying little plus little equals big, little plus little equals big. Then I can subtract these two because, where is it? Oh, because of what I had circled. So I showed these were congruent, so I can subtract them. Wait, I gotta put my substitution first. Sorry about that. Substitution. These two pieces are equal right here. So I can say these two pieces are equal. And then I can do the subtraction to get down here. So now I have shown BC, that's going to be like 4 little marks, is equal to FE. Just in the yellow, I have opposite sides congruent. So if opposite sides congruent, then you have a parallelogram. And you're done. All right, I'm going to go ahead and stop the notes because this was a really long set. Appreciate it. Have all of your notes out when you're doing your worksheet so you can see, first of all, these proofs, and you can see these reasons right here because you will be writing these statements in your homework or in your worksheet. Thank you.